Okay, so Pythagorean theorem is one of the things about right triangles that's special, but in general, right triangles are particularly special. There's a lot of things about them that are kind of like quirks in geometry that that work with right triangles that aren't going to work with any other type of triangles. So what we're going to talk about today is two specific types of what we call special right triangles that have patterns to them that you just need to memorize. So the first one of these is a 45, 45, 90 right triangle. So I'm going to go back for just a second. This is a right triangle right here. All right, think about if you know that a triangle has two equal angles, then what do you know about that triangle? If two of the angles are equal, then two of the sides are also equal, which means it's what kind of triangle? Isosceles. It's an isosceles triangle. This is a particular kind of right triangle called an isosceles right triangle because both of the angles are 45. So the other two angles are 45, which means that both of the legs then are what? Equal. So both of the legs have to be equal. So in a right triangle that's 45, 45, 90, two of the legs are going to be equal. So for example, in this case, in this special right triangle picture that I have right here, both of the legs are 12, and you know that they have to be the same because both of the angles are 45. So if I go to figure out and use the Pythagorean theorem to figure out what the hypotenuse would be, how would I plug this into the Pythagorean theorem? 12 squared plus 12 squared equals c squared or x squared or whatever you call this one. And it's 144 plus 144 equals c squared. 288 then equals c squared. And to finish it up, I take the square root of 288. Now, on your calculators, what I want everyone to do is go to mode and change to math print. So take your calculator and go to mode. If it's already there, then you're good. Math print. It's like the bottom one says classic. Switch. If it's already on math print, you're good. Just hit quit or clear or get out of there. If it's not on math print, change it to math print. What that's going to do is that's going to simplify the radicals for you. So that's going to take the radical and instead of writing it as a decimal, it's going to write it as a simplified radical. So go ahead and do the square root of 288 on your calculators. No, just change it. We're not doing that until we do circles. So it should say 12 square root of 2, right? So that's a simplified radical, all right? Does anyone know what that means, simplified radicals? No? Let's talk about what that means for a second. So basically, when you do the square root of something like 36, what do you get? 6. Why? Because 6 times 6 it's a perfect square, right? 36 is a perfect square. A whole number multiplied times itself gives you that number. So this is really easy to take the square root of. If you have something like this, square root of, let's see, 45. No, that one won't. Square root of 40, what does that give you? It's going to be in between 6 and 7, somewhere in between 6 and 7. And you can do a couple different things. You can either leave it like this, which is for the most part fine with me, all right, or you can figure out what the decimal is, which if you're in classic mode in your calculators, it will give you the decimal, or you can simplify the radical. And simplifying the radical is essentially like when you take a fraction and reduce it. It's like reducing your radical. So what you want to do to simplify a radical is we've got this number 40, all right? Can I break 40 down into anything? What can I break 40 down into? What multiplication problem could I break that down into? 10 times 4. All right, anything else?
5 times 8.
5 times 8. 20 times 2. All right, a bunch of different things. I'm going to pick 4 times 10, and here's why. Square root of 40 is the same as the square root of 4 times 10. And the reason I picked 4 and 10 is because what's 4? It's a perfect square. I can take the square root of 4. What is it? 2. So I can take that and get rid of it. I can move it to the outside because the square root of 4 is 2. So that would be 2 times root 10. And that's called the simplified radical version. All right? So the simplified radical essentially just means breaking down this number in here into perfect square factors and simplifying those. And it makes it smaller. So now that's our simplified radical. So try that with, like, let's say we had, trying to think of another one that would be Let's do 125. Let's do 125. What multiplication problem could you break that into? You could do 5 times 25. So instead of writing it as 125, I'm going to write it as root 5 times root 25. Are either of those perfect squares? 25. What's the square root of 25? 5. So the simplified radical version of this would be 5 root 5. Because this one simplifies to 5. This one I can't simplify, so that's what I'm left with. So here's the simplified radical version. All right, so that's my simplified radical. So that's all that means. Okay? So you're breaking it down into factors, and you want to pick a factor that's a perfect square. Good news is your calculator will do it for you, so you don't really need to worry about it too much, okay? So when we write something as a simplified radical form, if your calculator's in math print and you get something like this, like 5 root 5, and you're like, wait, I don't know what that means, that's what this means. That's the simplified radical version, okay? So on your calculator, do square root of 125. 5 square root of 5, right? So it should give you 5 square root of 5. That's where that comes from, because it breaks it down into simplified form. So going back then to what we had before, which was c squared equals 288, which is what we had from this one right here. What factor could I break 288 down into? I can break that down into square root of 288 is the same as square root of 144 times square root of 2. And what's the square root of 144? 12. So that's why that's the simplified radical. All right? Because it breaks down into 144 times 2, and the square root of 144 is 12. Okay, so that's where that came from. Now, in a... Do you notice anything here? Juan? There's two 12s here, and there's a 12 right there. Okay? So in a 45, 45, 90 triangle, the pattern is that if this is your leg, let's call it L, and your other leg is also L, which it's going to be because it's an isosceles triangle, then the hypotenuse is always L times the square root of 2. So if I give you this triangle, and I say, this is a 45, 45 right triangle. If this is 7 and this is 7, what's this? 7 square root of 2. All right? Every time, 100% of the time across the board. All right? So if I give you this one, and this is 45, 45, 90, and I tell you that this is 9 root 2, what are the legs? 9. They're both 9. All right, and if you plug that into the Pythagorean theorem, you'll find that that works. But the shortcut here is you don't even have to plug it into the Pythagorean theorem. It just works always. All right, a 45, 45, 90 triangle is always going to be L, L, L root 2. All right, always. So then what would I do if I had this? 45, 45, and this were 11. How would I find the L here? There's no root 2 there. So how do I find that? Where'd you get that? That's not necessarily going to work because you're not dividing by 2. You're on the right track, though. Okay, yes. Let's talk about why. This is L, right? This is our L leg. What's this one in the, let's call it the parent triangle. What's this one? It's the hypotenuse. So that means if this is L and this is L, this is what? L radical 2. So that means 11 equals what? L radical 2. So then how would I get L by itself to figure out what L is? Divide by radical 2. So over here what happens? Those are gone, so I have L. And I've got 11 over radical 2. I can't have a radical in the bottom of a fraction. It's like having a fraction in the bottom of a fraction. You don't want it. So on your calculators, do 11 divided by radical 2.
Give me 11 radical 2 over 2.
11 radical 2 over 2. All right? You can't, yeah, that's the answer. You can't have a radical in the bottom. So to get rid of a radical in the bottom, you do this. What is this? Root 2 over root 2?
1.
It's 1, right? So I'm not doing anything except multiplying by 1. What happens when you do root 2 times root 2? What happens with the roots? They disappear. Root 4, which is what? 2. So that makes those turn into a 2. And then on the top, I've got 11 root 2. All right? Point is, plug it into your calculator. It will give you that. Okay? We're going to spend more time with simplifying radicals a little bit later, but right now, for the most part, just do it in your calculator.
I remember what I did.
Yeah. All right, so every 45, 45, 90 right triangle will always be L, L, L root 2. So in this one, find the value of x. So if this is 45 degrees, what's this one? 45 degrees, which means if this is 7, what's this? So that means x is what? 7 radical 2. Perfect. Okay? Down here, I need to find x here. If this is 3, what do I have to do to find x? 3 equals x square root of 2, because that's my x. All right, remember this is the hypotenuse, so that's your root 2. So then what do I do? Divide by root 2, divide by root 2. On your calculators, do 3 divided by root 2. Always in a 45, 45, 90 triangle? Yes. Do you get 3 root 2 over 2? Yes? All right. So 3 root 2 over 2 equals x. So when do you have to divide by the radical? When the hypotenuse is not a radical. So when the hypotenuse is a whole number, you have to divide by the radical. And in this case, you always divide by radical 2. Okay, 30, 60, 90 is the other special right triangle that we're going to talk about. In a 30, 60, 90 triangle, the relationship is the short side is s, the hypotenuse is double that, and this longer leg is s radical 3. All right, so the short side is s, the hypotenuse is s times 2, or just 2s, and then the longer leg is s root 3. And you know that it's the longer leg because it's across from which angle? The 60-degree angle. Because 60 is bigger, so that one has to be bigger. So in this triangle right here, if the short side is 6, the hypotenuse is 12, and the longer leg is 6 radical 3. All right? So in a 45, 45, 90 triangle, it's radical 2. In a 30, 60, 90 triangle, it's radical 3. There is no way around this besides to memorize it. All right? There's just no way. Jennifer can attest to that. All right? There's not any way around it besides just to memorize s root 3, 2s. All right? It's not, or I mean, you could do the Pythagorean theorem every single time, but there's no way around making this easier than just memorize the 2 right triangles. Luckily, there's only 2. All right? 45, 45, 90 triangle is L, L, L root 2. 30, 60, 90 triangle is s, 2s, s root 3. All right? And the shortest side is just the s. The longest side is double that. And the longer leg, so the one in between, is s radical 3. Okay, so at your boards, I want you to try these two. All right, so for both of them, you're finding x and y, and these are 30, 60, 90 triangles. If you have questions, let me know.